Hello students, today we'll discuss how to draw an ellipse by using focus directrix method. Now so as to draw an ellipse by using focus directrix method, the statement says construct an ellipse when the distance of the focus from the directrix is equal to 50 mm and eccentricity is equal to 2 by 3. So we have to use this data so as to draw an ellipse. Now focus directrix, so initially we'll draw a directrix. So this is Directrix. Now on this Directrix, so as to construct an ellipse, first locate one point, an arbitrary point. This point is P, which is there on the Directrix. Now from this point P, we'll draw the axis of an ellipse. Now this axis obviously will be exactly at an angle of 90 degree to this Directrix. So we'll use protractor so as to draw an ellipse or axis. Now this axis will be the major axis of an ellipse. So this is nothing but an axis of an ellipse. Now on this axis we'll get the focus. Now ellipse will have two foci, one on left side and one on the right side. So left side, right side. Now the distance of the focus from the directrix is equal to 50 mm. Now this is the point P, which is there on the directrix. Now from this point P, exactly at a distance of 50 mm, one focus, that is F1, will be located. Okay, so we'll locate that focus first by using 50 mm. So here we'll get this 50 mm. So we'll get the focus F1. Now this focus is on left side of the axis. Now the distance 50 mm is located. Now we have to use an eccentricity. Now this eccentricity gives you idea about the number of divisions which we have to make between P and F1 or PF1. So 2 by 3, so 2 plus 3, 5 divisions we have to make for the distance PF1. So this actually distance is given 50 mm. So it will be easy for us to divide this distance PF1 into 5 equal parts, measuring 10 mm each. Now the concept of an ellipse, obviously this ellipse comes under the conic section. So when a cone is cut by a cutting plane, so we'll get number of curves or sections. So this is one of that section, ellipse. Now this eccentricity 2 by 3 is equal to less than 1, which is obviously for an ellipse. So this 2 and 3, so we have to come on left side from this F1 2 divisions, or the denominator 3 divisions from P1, so as to locate point V. So V is nothing but the vertex which comes on the curve. At this point V is there on the axis of the ellipse. Now once you have located point V, we'll draw a right angle, a line exactly at an angle of 90 degree. Now we'll use a line. We'll draw a curve passing from this point F1 and considering center as V. So we'll get one point, that is the merging point of the line, vertical line or perpendicular line which we have drawn from point V. So this will be exactly at an angle of 90 degree. That you have make sure that you are drawing this line exactly at an angle of 90 degree. So we'll have 3 points, V, A and F1. So with the use of PA, we'll draw one line. And we'll draw one more line which is exactly at an angle of 45 degree, which will pass from this focus which we have located. So at an angle of 45 degree, we'll draw this line. So this line is to be drawn exactly at an angle 45 degree. So we'll get one meeting point. This point we'll consider it as Q. Now from this point Q we'll draw a line perpendicular to axis. So this will be the second vertex, that is V dash, which will be on the right side on the axis. Now this distance V dash is to be divided into equal parts possibly. Now this distance comes out to be equal to 10.105 millimeter. So possibly will 8 millimeter distance will consider so as to have divisions. So it depends on the constructor exactly how many divisions is making. And with this division we'll draw perpendicular lines to axis from this point. Now make sure that this line is touching the line PQ which we have drawn. The more number of lines, the perfect curve or the ellipse will get. Now we'll consider this as point 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So 1 here we'll get 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash and 10 dash. Okay. Now with this information, now we'll locate the points which are there on the curve. Now how to locate those points? First take distance 1 dash and rounder. Keep pointer on F1 and cut the line 1 dash on both the side of the axis, that is on above the axis and below the axis. Same way we'll consider distance 2 dash. Keep again pointer on F1 and cut the same line. 3 dash. Keep pointer on F1, cut the same line on above and below the axis. Take distance 4 dash. Keep pointer on F1. Cut the line on below and above the axis. 5 dash. Keep pointer on F1. Cut the line above and below the axis. 6 dash. Keep pointer on again F1. 7 dash. Keep pointer on F1. Cut this line above and below the axis. 8 dash. Keep pointer on F1. Cut the line above and below the axis. 9 dash. Keep pointer again on F1. Cut the axis or cut the line above and below the axis. 10 dash. So obviously if we take distance from V dash to Q, it will be equal to F1 V. So this will be measured. So we have all points got over here. So these are the points. So by using French curve, we have to join all those points. So how to use this French curve? So when you are using a French curve, make sure that minimum 3 points are there on the French curve. So like this. So these are the 3 points. Now minimum 3, maximum you can try to locate more number of points, but minimum 3 points must be there. So this is on the above the axis, and exactly below the axis we have to complete. So this is how we have completed with an ellipse by using focus directrix method. So on both the side of the axis we have to complete the curve by using French curve or instrument French curve. Now we have to label this curve properly. Ellipse. 50 millimeters. So this is the way we have to construct an ellipse. Now similar to this, the same method is to be used so as to draw parabola and hyperbola. For parabola, for ellipse, the eccentricity E is always less than 1. For parabola E is equal to 1. Eccentricity is 1, and for hyperbola eccentricity is greater than 1.